Hello and welcome to my video demonstration observing the spanning tree protocol, or STP. In this lab, we're going to use Packet Tracer to build this network of 5 switches in a redundant switch network. And then we're going to go ahead and take a look at how spanning tree works and observe it. And then we'll finally get into observing a broadcast storm. So let's get started. So I'm going to go ahead and go into Packet Tracer. And the first thing I need to do is start creating this network. So let me bring this off to my other monitor so I can see what I'm building. And in Packet Tracer, if I want to build a network, down here in the bottom left corner is the menu for all of the devices I want to connect. So I'll go to Network Devices, select Switches, and then I'll bring up 5 2960 switches. There's my 4th switch and my 5th switch off here. Now the next step I want to do is actually I've got the alignment tools turned on. Let me get these aligned better. And the next step I will do is I'll go ahead and create my links between the switches. I believe now I'm going to configure the names as the second step. So let's do that. So I'll go ahead into the switch and I'll click on it. I can go to the config tab and I can call this S1, and I can even change the host name down here, S1. And that device is changed to S1. And S3 is right here, so I'll make this one. And go ahead and do the same thing for S2. And then S4, config tab. And lastly, we'll do S5. So I've got my devices named, and notice they show up here under this. So now I can start creating my links, and this is the icon for connections. And then I'll go ahead and I'll create a crossover connection between the devices. So on this one, it's 02 to 02, new connection, 1 to 1, new connection, that's going to be 1 to 1 again, 1 to 1. And my next connection will be 2 to 2. And lastly, I've got from 3 to 2 over here. And my last connection is from S2, 3 to 1. So I've got this built, but I've got a lot of stuff. It's really hard to see. I've got so many labels. It's hard to see which cables are going where. So what I like to do is I like to create my own labels. Then those I can move around. I can't click and drag any of these labels. If I move this around, it doesn't really help me too much. So what I'm going to do is I'm going to go into my options. Actually, first let me make new labels. So I'm going to go to the notes and I'll make a couple of labels. And I can even label the devices. And if I click and drag them around where I want them, I can put that FA02 right here. I can put the 01 right here. And then I can make that S2 is this one. I'm just generally positioning them. And now I can go ahead and turn off some stuff. So notice here I have a few things turned on. If I go into my options and then preferences, I want to turn that off because that's been getting in my way. The aligned logical workspace objects, that's making it hard for me to move my labels. I want to turn off port labels, and I want to turn off device name labels and device model labels, because when I do that, now the only labels I have are the ones I created, and I can move these around anywhere I want to make this look better for me. Okay, so I've gone ahead and I've created all my connections between the switches. I've given them labels, I've named them, and I've created new labels for all my ports that I can move around, because I really just like to be able to see where all my links are, what connections are going to where, and see all of my labeling where I can move them around and not have stuff hidden and overlapped. So the next thing we want to do is we want to look at the root bridge. And in this example, your example may be different because this is done dynamically. We can influence that and we'll get into it, but if yours does not look like this, that's fine. But in this example, S5 is my root bridge. And the way I can tell that is because if I look at this link between S4 and S2, if one of them were the root bridge, then this would be the best path to root between them. And the same can be said over here. If S1 or S3 were the root bridge, then the best path to root for the other switch would be across this link. So this kind of through the process of elimination, I can see that S5 is my root bridge. And I can actually issue the command show span, and show spanning tree. It actually says right here, it says this bridge is the root bridge and these two parts are forwarding. So now let's make sure that every lab is looking the same. So we'll make S1 the root bridge. And the way we do that is we go into the command line, I say, and I'm going to issue the command spanning tree VLAN1 root primary. And this will make S1 the root bridge. And as we watch this, we should see, yeah, we are seeing some changes going on. Some of these lights have changed to amber. And what's going on here right now is these switches are all trying to renegotiate and find S1 is sending a BPDU out, telling all the other switches that I'm the root bridge. And these other switches are looking for a better path to root. And I'm going to fast forward this a little bit. Click the fast forward button. And now we see our new network looks like this. We have S1 as the root bridge and S4's best path to root bridge. It's got two options. It's actually got three options. It can go through S3, S5. It shows that this is the best path to root for it. Your example might have S4 choose to go this path. And what we're looking at here is I've got these two links that aren't being used, but I still have a path to where every switch can send traffic to every other switch. So the next thing we want to do is take a look at what happens if a link goes down. So I'm going to go into S3 interface fast Ethernet 02, and I'm going to turn this interface off. So I can go into the command line on the switch, and I can go, I'm already in global config mode, so all I have to do from here is type interface and I will issue the command shutdown. And when that port shuts down, look what happens. Now S3 needs to find a better path, or needs to find a path to get to S1. So I'm going to hit fast forward to let this converge. And as you can see now, our topology changes. With this link down, S3 and S4 have to communicate and agree to activate this link between them. So now S3 can still send traffic to S1. And we're still a loop-free network. We don't have any active redundant links, but we converge and find other paths when a link goes down. And if I type no shutdown, now we'll see this again. We're starting to see both ports are in a blocking state as they negotiate and determine for sure that we need to activate this link. And I'll fast forward again. And now we have our network restored to its original spanning tree topology state. So the next thing we're going to do is let's go and create and observe a broadcast storm. For the first thing I want to do is I want to add a PC to my network so I can send a broadcast out. And then I'll go ahead and create my connection. And let's go to 03. And I'm going to connect it to my PC. And then I've actually got a label here. Put this right here. That's port 03 now. And I can move this out. And then I go ahead, I do actually have a root bridge. That's my root bridge label. The next thing we're going to do is I'm going to disable spanning tree on all devices. So to do that, I need to make sure I'm in global config mode. In this case, I had to type exit to get out interface config. and I'll type spanning tree, no spanning tree. No spanning tree VLAN mode 1. And I'm going to go ahead and copy this so I don't have to type, whoops, I didn't get all of it. I'm going to go ahead and copy this so I don't have to type it over and over again. That was S1. And on this switch, enable configure terminal, and I'll paste that in there also. In this switch, and I'll paste that there, S4. Oops, I did not hit enter. Let me make sure I hit enter to complete that command. And I will paste that in there. So I believe I did it. I might have not hit enter on everything. So let me just double check. That one I did, and that one I did. Okay, so now if we look at this, I see no ports in a blocking state. That tells me that spanning tree is not running. If you have an amber light at this step, go and check all your devices and make sure that you turned off spanning tree. So now let's create that broadcast storm and see what happens if I have a looped network. So I'm going to go into my desktop and I need to put an IP address on my PC. And I needed to make that a 1010. So I'll give that an address, and actually in the example I didn't do a default gateway, but it doesn't hurt to have it in there. So let me go into my command prompt and let's create that broadcast storm. But actually before I do this, first I need to go into simulation mode. So let's turn on simulation mode, and I have this button here where I can toggle my filters. I want to turn them all off. Now when I edit them, I can just turn on the one I want instead of going in here and unchecking everything. The only traffic I'm going to monitor will be ARP broadcasts. And then let me create that broadcast. The easiest way to create a broadcast is to ping something if it's not in your ARP table. So if I look at my ARP table, I have nothing in there. So as soon as I ping something, I'm going to have to create an ARP request to find the MAC address for that IP address I'm pinging. So here's my ping. The first thing it's going to do is send an ARP request because it doesn't have an ARP entry or a MAC address for the IP address that I'm pinging. As I go through each step by clicking the next button, it'll S3 received that frame. It made a copy of it, send it to S1 and S4. Now S1 and S4 are going to make copies of it and send it everything. And this is where the broadcast storm begins. These frames that started from this direction are going to be sent back, and we don't really want that. So now we see these frames being sent throughout the network, and basically what a broadcast, remember the rule of that is I'm going to forward it out any port except the port I received it on. So when we have a looped network, we can send traffic back indefinitely. And actually in this case, now we see the PC receiving a broadcast that it sent out. And this is going to continue forever. This will continue. We see a lot of traffic here. It's going crazy. And when you do this on your own lab demonstration, you may or may not get this to work. Sometimes packet tracer, I've seen this crash packet tracer, I've seen it delay it. So don't panic if you don't get this exact result. But this is what happens when you have a broadcast storm without having spanning tree going. And this is the importance of it, because now these switches are receiving so much traffic that they can't process anything, and they'll stop forwarding frames. They'll get overwhelmed. The PC will actually get overwhelmed too, because it keeps receiving this broadcast back from S3. And you can I've actually seen PCs freeze in broadcast storms where you can't even move the mouse because the processor is handling so many incoming broadcast frames that it can't do the normal desktop functions. So anyway, I hope this has explained the purpose and the reason we have spanning tree and the role and the port states. We have to have a root bridge, and every switch is going to find the best path to the root bridge. And this prevents us from having loops in our network.